In this video, I will walk you through free response question number 4 from the 2017 AP Calculus exam. This problem is primarily about differential equations. At time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. And the internal temperature of the potato is greater than 27 degrees Celsius for all times greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation dh dt equals negative 1/4 times h minus 27, where h of t is measured in degrees Celsius and h at 0 equals 91. Part A. Write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. Whenever they ask us to find the equation of a tangent line, we love to use point-slope form because we know that all we need is a point and the slope. Since the temperature is a function of time and not x, I will write my equation with t. They already gave us a point. H at 0 is equal to 91. So we have the point 0, 91. All I need is the slope. The function dh dt will give us the slope at any point. We just need to evaluate dh dt at the point 0, 91. Since dh dt is only a function of h, all we have to do is plug in 91. This turns out to be negative 16, so the slope of the tangent line is negative 16. Now that we have a point and the slope, we can easily write the equation of the tangent line. It will go y minus y, so y minus 91, is equal to the slope, negative 16, times t minus t1, which is 0. We don't really need the minus 0, so let's just write this. Adding 91 to both sides, the equation of the tangent line becomes y equals negative 16t plus 91. We can now use this equation to approximate the internal temperature of the potato at time t equals 3. All we have to do is evaluate this equation at t equals 3. This turns out to be 43 degrees. The equation of the line tangent to the graph of h at t equals 0 minutes is y equals negative 16t plus 91. The tangent line approximation for the internal temperature of the potato at t equals 3 minutes is 43 degrees Celsius. Part B. Use the second derivative to determine whether your answer in Part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. Here's the theory. On intervals where the second derivative is positive, h of t will be concave up. On intervals where the second derivative is negative, h of t will be concave down. If h at t is concave up, the tangent line approximation will always give an underestimate because the tangent line is always below the curve. If h of t is concave down, a tangent line approximation will give an overestimate because the tangent line in this case is always above the curve. We can find the second derivative by taking the derivative of the first derivative. Let's bring down the negative 1/4, and then we will take the derivative of the rest term by term. The derivative of h will be dh dt. The derivative of 27 is 0, so I don't need all of this space. So I have this now. We need to write this in terms of h and or t. We have to get rid of dh dt. So let's do a substitution. Looking right here, we see that dh dt is equal to this expression. So I can take this expression right here and put it right here. So now we have this. We can simplify this a bit by multiplying negative 1/4 times negative 1/4 and writing positive 1/16. Now that we have the second derivative, we just need to figure out whether this expression will be positive or negative during the time interval while the potato is cooling down. Looking back at the setup of the problem, we were told that the internal temperature of the potato is greater than 27 degrees Celsius for all times where T is greater than 0. So they are telling us that H is greater than 27 degrees for all T greater than 0 minutes. In other words, H is always greater than 27. If that's the case, then this expression for the second derivative will always be positive. H is always greater than 27. This is going to be a positive number. And if this is positive, then H of T is always concave up, and the tangent line approximation is an underestimate. Kabam! Part C. For T less than 10, an alternate model for the internal temperature of the potato at time T minutes is the function g that satisfies the differential equation dg dt equals negative g minus 27 to the 2/3 power, where g of t is measured in degrees Celsius and g at 0 equals 91. Find an expression for g of t. Based on this model, what is the internal temperature of the potato at time t equals 3? This is a separable differential equation. So we can solve this by getting all of the g's on the left side of the equation and all of the t's on the right-hand side of the equation. Let's begin by moving this dt over to the right-hand side by multiplying both sides by dt. So now we have the t's on the right. We want all of the g's on the left though. So let's move this expression over to the left by dividing both sides of the equation by g minus 27 to the 2/3 power. Now I have all the g's on the left and the t's on the right. It'll be a little easier to integrate if I rewrite this as g minus 27 to the negative 2/3 power. We can now solve the differential equation by integrating both sides of the equation. On the left side, this is going to be a mental u substitution. We're thinking that u is g minus 27. That means u prime is only 1. When you do the u substitution, you always end up dividing by u prime. But dividing by 1 changes absolutely nothing, so we can just ignore that and go ahead with the antiderivative. So, using the power rule of integration, we will take the u and we will add 1 to this exponent. That's going to make positive 1/3. Then we divide by the new exponent. Dividing by 1/3 is the same as multiplying by 3. And yes, this is u. And normally I would say plus c right now, but I'm going to save the plus c for the right-hand side of the integral. The antiderivative of negative 1 is negative t plus c. Speaking of plus c, we need to figure out what this is using the initial conditions that we are given. This says when t is 0, g is 91. So let's put 0 in for t and 91 in for g. So now we have this. Negative 0 is nothing, so let's just simplify over in this area. 91 minus 27 is 64. 64 to the 1/3 power. In other words, the cube root of 64 is 4. So I'm looking at 3 times 4, which is 12. So we just figured out that c is 12. Let's put 12 back into the equation right here. We were asked to find an expression for g of t. That means we need to get g all by itself. Let's divide both sides of the equation by 3. Now I have this. I can get rid of this 1/3 power by raising both sides of the equation to the third power. Then finally, I can get g by itself by adding 27 to both sides of the equation. So this is the first half of what they asked us to find. Now, based on this model, what is the internal temperature of the potato at time t equals 3? In other words, let's just evaluate this equation at t equals 3. Putting 3 in for t, we have this. The 3's cancel out, so we have -1 plus 4, which is 3. 3 to the third power, and then plus 27. But this is 27 plus 27, which is 54. Based on this model, the internal temperature of the potato at t equals 3 minutes is 54 degrees Celsius. By the way, notice how I'm going out of my way to mention my units. Anytime you're doing a problem where they gave you units, mention all of your units in your answer. In this case, minutes and degrees Celsius. Just for fun, let's link our answer to part C back to our answers from parts A and B. In part A, we used a tangent line approximation to estimate that the internal temperature of the potato at time t equals 3 minutes would be 43 degrees Celsius. Then in part B, we decided that this tangent line approximation would be an underestimate. Then in part C, we found out that the actual temperature of the potato at time t equals 3 minutes is 54 degrees Celsius. So our estimate of 43 degrees was an underestimate, just like we thought.